This video is about the first and second derivatives and their graphs. Fill in the blank about the concepts. When f prime of a equal to 0, the point a f of a could be maximum, minimum, or stationary inflection. When f prime of x greater than 0, which means f of x is increasing. When f prime of x less than 0, then the function f of x is decreasing. When f double prime of a equal to 0, the point a f of a is inflection point if f double prime of x has a sign change. At x equals a. When f double prime of a equal to 0, the point a f of a is not inflection. If f double of x has no sign change at x equals a. In other words, a f of a is an inflection point only it has satisfied two requirements. One is f double prime of a equal to 0. Second, the f double prime of a has a sign change at x equals a. When f double prime of x greater than 0 means the function is concave up. When f double prime of x less than 0, the graph is concave down.
Let's go to conclusion. For f prime of x less than 0, which means the function is decreasing. F prime of x greater than 0, the function is increasing. F double prime of x less than 0, the graph is concave down. Then for f double prime of x greater than 0 is concave up. Concave down and decreasing will be second one. Concave down increasing will be the first one. Concave up decreasing, this one. The third one. Concave up increasing will be this graph. For f prime of x equals 0, it will be stationary point, minimum, maximum, or stationary inflection point. I use SIP stand for that. For concave down, it will be maximum point. Concave up, it will be minimum point. If the first derivative equals 0 and the second derivative equals 0, it will be stationary inflection point. For second derivative of x equals 0, it will be point of inflection. If the first derivative is less than 0, which means the function is decreasing. So this point for function is increasing. Maximum or minimum of f of x will be changed into zeros of f prime of x. For stationary point of inflection will be changed into zeros also. For non-stationary point of inflection will be maximum or minimum of f prime of x. Zeros of f prime of x. This 0 is not maximum or minimum. It will be changed into maximum or minimum of original function. For maximum or minimum, it's not zeros. It will change into non-stationary point of inflection. If the point is maximum, also it's 0 like this, or it's a minimum but also 0, it will be the stationary point of inflection of f of x. This is the graph for f of x. Then we will sketch the corresponding graph of f prime of x. We know this is the stationary point of inflection. So for f prime, it will be 0. For this part of graph, it's increasing. This one is also increasing. So this will be positive for f prime of x. Positive means above x-axis. So we can predict the graph like this. For this stationary point of inflection, will become 0 in the graph of f prime of x. This part is decreasing. This part still decreasing. So negative, negative. Negative means below x-axis. So we could see the graph will be like this. This is a maximum point. This is a minimum point. And this is a non-stationary point of inflection. Maximum or minimum will go to these zeros. And a non-stationary inflection point will be maximum or minimum. This part of graph is decreasing. So this is a negative, negative. This part is increasing, positive, or increasing. So this is positive. We could say this is a minimum point. So we can connect like this. For this graph, this is a minimum point, maximum point, non-stationary point of inflection. Go to minimum and maximum will become zeros. Point of inflection will be minimum or maximum. Increasing, increasing, so positive, positive. Decreasing here, negative. Decreasing here, negative. Positive means the graph is above x-axis, so that your graph will be like this. We are given the graph of f prime of x. We try to sketch the graph of f of x. From f prime of x to f of x, the answer is not unique. This is 0. And check the sign for f prime of x, negative or positive, which means the graph will be going down and going up. This 0 will be minimum point. So this minimum point can be anywhere on this line. This is also 0. Above x-axis will be positive, here's a negative. So going up, going down. This will be the maximum point. We can sketch the graph like this. Let's go to this graph. This point is 0 and also is a maximum point. Since the graph is below x-axis, it's a negative, negative. It will be stationary point of inflection. So we can sketch the graph going down, then going down, like this. This time, this point is 0, and also minimum point, stationary point of inflection. Positive or positive because it's above x-axis. So the graph will be like this. For this one, this is a 0, 0, and a positive, negative, negative, positive. So positive means increasing, then decreasing for negative. This point is a maximum. This is going down, then going up. So this point is a minimum. This will be point of inflection. Basically, it's a non-stationary point of inflection. And this one, we could say the sign is negative because it's below x-axis, positive, positive, negative. So this point will be minimum point. And this point will be maximum point. And for this maximum will be point of inflection. We can sketch the graph like this.
Now we use this table to make a concept more clear. For f of x, minimum, maximum, then the first derivative definitely equal to 0. Stationary inflection point is equal to 0. When the graph is increasing, means the first derivative is positive. Decreasing function, it will be negative. For second derivative, if it's an inflection point, then it will be equal to 0. Concave up when the second derivative is positive. When the second derivative is negative, which means the graph is concave down. And also, if it's a minimum points, which means it's concave up, definitely it's a positive. When it's a maximum, it's concave down, so it will be negative.